Hello everyone, I welcome you all to this quick solutions of the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 5A Paper 1 Code C and D. So let's start with the first section, students. So students, this first section contains 5 questions. Each question has 4 options, out of which only one single option is correct. So let's start with question number 21. For a chemical reaction A converting into product, the mechanism of the reaction postulated was as follows. So the reaction mechanism has been given to us. It is further given that the reaction occurred with individual rate constants K1, K2 and K3 as shown above. Determine the activation energy for the overall reaction if the activation energies associated with the rate constants are EA1 is equal to 180 kJ, EA2 is equal to 75 kJ and EA3 is equal to 253 kJ. So students, if we talk about the rate of this reaction, so the second step is the RDS in which B is converting into C. So if we talk about the rate of this reaction, the rate can be written as K3 times the concentration of B. Now students, this B is an intermediate, so it is not going to appear in the rate law. So we need to substitute the concentration of B in terms of the reactant, which is A. So for that we can use the first equilibrium. So from the first equilibrium we can write that K1 by K2 is equal to concentration of B raised to the power 3 divided by concentration of A. So this means that the concentration of B will be K1 by K2 into concentration of A and everything raised to the power 1 by 3. Okay, so all that is left now is to substitute this value of concentration of B into the first expression. So students, we have the rate is equal to K3 into K1 by K2 into the concentration of A whole raised to the power 1 by 3. So students, if we talk about the overall rate constant, so the overall rate constant, we're going to call it as K overall. This can be written as K3 times K1 by K2 raised to the power 1 by 3. So this means that the activation energy overall can be written as EA3 plus 1 by 3 times EA1 minus EA2. So all that is left now is to substitute the values of EA3, EA1 and EA2, students. So we can put those values. EA3 is 253, EA1 is 180 and EA2 is 75. So students, if we solve this expression, we're going to get the value of EA overall equal to 288 kilojoule. So students, if we look at the options, we have to mark the option D as the correct answer to question number 21. Let us look at the next question now. Question number 22. The equivalent weight of Cl2 in the given disproportionation reaction is. So students, if we talk about the disproportionation reaction, we know that the N factor for Cl2 in this reaction is equal to 5 by 3. So students, if we talk about the equivalent weight, it can be written as the molecular weight divided by the N factor. So the molecular weight of Cl2 is 71, whereas the N factor is 5 by 3. So this becomes 3 by 5 into 71 if we express it in the form of the options which are given. So students, we can clearly see that for this question we have to mark the answer as option A. Let us look at the next question now. Question number 23. Which of the following is correct order regarding the strength of pi bonds? So students, if we talk about the strength of pi bonds, these depends upon the extent of the overlap. So bond strength is directly proportional to the extent of overlap. So students, if we talk about the overlap, the extent of 2p overlap is greater and it leads to a stronger bond, followed by the 2p3d. So why do we have this 3d over here, students? Because the 3d orbitals are at an angle with the axis, which leads to a better overlap with the 2p orbital. Next, if we look at the options, we have to talk about 2p3p and 3p3p. So 2p3p will lead to a better overlap as compared to 3p3p. So 3p3p orbitals are large orbitals and the extent of overlap is not very great between them. They do not lead to the formation of strong bonds. So this is the correct order of the strength of pi bonds obtained after the overlap of the orbitals mentioned. So if you look at the options which are given to us, students, we can clearly see that for this question, the answer has to be marked as option C. Let us look at the next question now. Question number 24. The standard reduction potential of Ag plus to Ag electrode at 298 Kelvin is 0.80 volts. The solubility product of AgI is 6.4 into 10 to the power minus 17 at 298 Kelvin. We have to comment on the E of Ag plus to Ag when Ag is dipped in a saturated solution of AgI. So students, we have to apply the Nernst equation for this question. So we have E of Ag plus to Ag equal to E naught of Ag plus to Ag minus 0.06 by 1 log of 1 by Ag plus ion concentration. Now students, in order to find out this Ag plus ion concentration, we have to use the KSP of the AgI. As it is mentioned that we have to talk about the saturated solution of AgI. So students, we can find out the solubility of AgI, that will be equal to the concentration of Ag plus ions. So we have S square is equal to 6.4 into 10 to the power minus 17, where S is the solubility. So this means that the value of S can be written as 8 into 10 to the power minus 9. So students, this Ag plus ion concentration is also equal to this number. So all that is left now is to put the values and find out the required potential value. So E naught of Ag plus to Ag value is equal to 0.8 minus 0.06 into log of 1 by 8 into 10 to the power minus 9. So this can be written as 0.8 minus 0.06 into 9 minus log 8. So this log 8 value is equal to 0.9. So this means that the term inside the bracket will be 0.81. So we have 0.8 minus 0.06 into 0.81. So on simplification, this gives us a value equal to 0.314 volts. So students, if we look at the options which are given to us, we can clearly see that we have to mark the correct answer as option C. Let us look at the next question now. Question number 25. In the given sequence of reaction, the product E is. So a series of reaction has been given to us. Let us try and solve this series of reactions. So in the first step, this given alkyl halide is allowed to react with alcoholic KOH. So students, the alcoholic KOH is going to cause E2 elimination, and after that further it is allowed to react with NaNH2. So in both these steps there are elimination happening, and if we talk about the product B, this is going to be a diene. So there will be a loss of HBr from the given substrate, which will lead to the formation of this. So this is the compound B which is obtained. Now it is allowed to react with CH2CHNO2 in presence of heat. So students, we have a diene and we have a dienophile. So this is the diel-Alders reaction. So if we talk about the diel-Alders reaction, students, we can figure out the product by writing it in this fashion. So we're going to have the formation of this compound. So this is the compound C which is obtained. Now this compound C is allowed to undergo reductive ozonolysis. So upon reductive ozonolysis, this is going to produce carbonyl compounds over here. So we're going to obtain this compound as the product D. Now students, this D is allowed to react with OH minus in presence of heat, which is the aldol condensation. So here we have the possibility of intramolecular aldol condensation, students, and we can see that this hydrogen will be more acidic, as the carbanion generated here can be stabilized by both of these groups which are present. So the carbanion shall be generated over here and it will make an intramolecular attack at the other carbonyl carbon which is present. So students, if we talk about the product which will be obtained in the first step, before heating there will be the formation of this compound, and when this is heated, students, there will be E1CB elimination due to the heating, and we are going to obtain This compound has the major product E. So if you look at the options which are given to us, students, we can clearly see that for this question, we have to mark the correct answer as option B. Let us look at the next section now, students.